Next, we are looking at the principal exercises. It says a function y of t satisfies the differential equation dy dt equals y to the 4 minus 6y cubed plus 5y squared. What are the constant solutions of the equation? That is question number A. So, a constant solution means that we have to have a solution where the function y just equals a constant value. So, in other words, that means that we have to find some solution such that y of t equals c, where c is just some constant. If y equals a constant function, what does that mean about dy dt? What is that going to equal? Well, the derivative of a constant is 0. So, let's now substitute the c and the 0 into our differential equation that we started with. So, our differential equation is dy dt equals y to the 4 minus 6y cubed plus 5y squared. So now I'm going to substitute 0 into the derivative's place and c into everywhere where I have a y. And then I'm going to solve that. So I'm just going to take out a common factor of c squared. So then I have c squared minus 6c plus 5. I'm going to factorize that further. So it's c, then we have c minus 5 multiplied by c minus 1, which means that c can be 0, or c can be 5, or c can be 1. So, the constant solutions will be that y of t is 0, or y of t is 5, or y of t is 1. Number B asks us for what values of y is y increasing. So we have the derivative of y in our differential equation, and we know that for a function to be increasing, it means that the derivative has to be greater than 0. So, I just want to know for which values of y is y to the 4 minus 6y cubed plus 5y squared greater than 0. So, we factorize it again in the same way. So, we have y multiplied by y minus 5 multiplied by y minus 1, which is greater than 0. So, this means that we just have to determine where this is actually true. So if we were to look at what this function will look like, it will look something like this. Well, we know that it's equal to 0 when y is 0, when y is 5, or when y is 1. So I'm just going to draw it like this now. Even though this is usually the x-axis, this is just to get the idea. So if you are unsure whether your function will go up or down first, you can just substitute a value between the 0 points into the function. So for instance, we know this is 0, this is 1, and this is 5. So you can just substitute some value in between here into the function and in between here into the function to see that it will look like that. So what this tells us is that our function will be greater than 0 when we have y between 0 and 1, or when y is greater than 5. Part C of the question is for what values of y is y decreasing. So we just have to know when is our function going to be less than 0. So that will be when y is less than 0, or when y is between 1 and 5. That is all of the problems in this week's TUT.